Hi class. So now we're going to start the next unit on trigonometric functions and graphs. So this kind of continues from where we kind of left off with the unit number 4. So basically, let's start with sine and cosine. So these are what we refer to as periodic functions. Okay, so what that means is they basically repeat themselves in regular intervals, or what we call cycles of the domain. So domain is the x part, and one cycle is called the period. Okay, so basically that's from when you end up at the same point that you started. Okay, and as with other functions, these also can be transformed. Okay, so at the top here you can see a graph of cosine x and sine x. So again, they're what we call periodic functions. Okay, so let's start with this transformation of cosine x. So if you look at the if you look at the inequality here, you notice how it's 0 to 2 pi. So why that's significant, it tells you how big your graph should be, and it also tells you should you do your graph according to radians, which involve pi, or should you do them with degrees. Okay, so like 0 to 360. So that's why that's significant. So let's start with the cosine x. So just like looking at the top there, so for y equals cosine x, if we do a table of values, so let's do a table of values, 0 pi over 2, pi, 3 pi over 2, and 2 pi. So if you notice what we're doing here, these are like the arms of our grid when we had the unit circle. And so this is 1, 0, negative 1, 0, 1. Okay, so let's graph the cosine function. So that would be, let's call this 1 and negative 1. So we start at 0, 1, and then we end up at pi over 2, 0, and then pi negative 1, and then we end up at 3 pi over 2 and 0, and then we end up at 2 pi and 1. Okay, so we can draw this out. Okay, so there's the cosine. Now, what we want to do for the next one here is, let's look at y equals 6 cosine x. Okay, so same thing. You should be familiar with that transformation, so that what that's going to do is it's going to transform the y values by a multiple of 6. So we're going to have the same x values, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so now we're going to have 6, 0, negative 6, 0, and 6. Okay, so I just took the same y values for y equals cosine x, and I just multiplied it by 6. So now what this is going to look like, so we have to expand the grid a bit here. So let's take that up a little bit higher and call that 6. And then take this a little bit lower and call this negative 6. Okay, so what we've got here is we start at 0, 6. We end up back at pi over 2, 0. Then negative 6 pi, 3 pi over 2, 0, and then 2 pi and 6. Okay, so what we've got here, it's a vertical stretch. Okay, so this is your y equals 6 cos x. Okay, and then let's look at the next one here. So negative 4 cos x. So now all we're doing is we're taking those same y values, and now we're going to multiply them by negative 4. So you're going to get negative 4, 0, positive 4, 0, and negative 4. Okay, so these are your new y values, and so same thing as before. We've got 0 and negative 4. Back here again, and then we've got so this is a reflection and a stretch, and then we've got 4 at pi, and then we've got this value, and then negative 4 and 2 pi. Okay, and there's your y equals negative 4 cosine x. Now notice how it asks for the amplitude and the range for each graph. So the amplitude is your maximum vertical displacement from the baseline. So the baseline is like your 0, y equals 0 line. So the amplitude for this one, for the one in green here, that amp is going to be equal to 4. Okay, for the 6 cos x, the amp is going to equal, amplitude is going to equal 6, and then for just the regular cosine x, the amplitude is going to equal 1. Okay, and then the range is, if we look at the 6 cosine x, it'll be from negative 6 to positive 6. So like we can write that as y is less than and equal to, or less than and equal to 6, and greater than or equal to negative 6. So that's for the 6 cos x, and then the negative 4, it'll be negative 4 y less than 4. Okay, so this is your range. Okay, so that was looking at that was looking at altering the y values. Okay, now let's look at altering the x values. Okay, so here we're looking at cosine 3x. So same, and so here notice we're talking about degrees. Okay, so now we want to do this according to degrees. So again, it's just a matter of taking your existing cosine x. So we've got for cos x, where we've got 0. Now we're not working with pi, so 90, 180, 270, 360. Okay, and so 1, 0, negative 1, 0, 1. Okay, so let's multiply those. So what are we going to alter here? So we've got the 3 in front of the x. So remember what that means. That means we're going to take the x value and we're going to divide it by 3. So now instead of so you're still going to have 0, and then 90, instead of 90 you're going to have 30. Instead of 180 you're going to have 60, and then 270 is going to become 90, and 360 is going to be 120. Okay, and these are going to go with the same y values. Okay, so this is y equals cosine 3x. Okay, so we're essentially still doing the mapping, and so now you can, let's call this 1 and this negative 1. So this is going to be 0, 1, 30 is going to be 0, and 60 is going to be negative 1, and then 90 is 0, and then 120 is going to be 1. Okay, so what you've done by that 3 in front is you've narrowed the width by a factor of 3. Okay, and then the converse here for this one is you're going to take the x value, and now we're going to multiply it by 3. Okay, so it's going to be 3 times bigger. And so here we want to go from 0 to 6 pi, right? So let's write that in. So we'll call this pi 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. Okay, and so here's your 0. So again, 0 is what I mean by the baseline. Here's 1, and then here's -1. Okay, so same values for the regular cosine, and now we're just going to multiply the x values by 3. So that's going to give us 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. Okay, and then we leave the y values the same as they were before, is 1, 0, -1, 0, 1. Okay, so you're going to have value there, and then 3 over 2 pi, so it's like pi and a half. So another one there, 3 pi, and then about 4.5 pi, and then 6 pi. Okay, and the last one here, let's combine the two. Okay, so let's take a regular, so this is, now we're going to do a sine function, and we've got a 3 in front and a 4 in front of the x. So let's just start with a regular sine function. Okay, so for a regular sine function, and we're going to work off of, now here you notice it doesn't mention to use degrees or radians. So in that instance, you could go either way. Okay, so I'm just going to go with the degrees here. So 0, 90. But if you see that inequality, that's either has pi in it or has degrees, then you have to make sure you stick with that. Okay, but in this case, because it didn't have it, it doesn't matter. You can go either way. Okay, so there's your regular y equals sine x. So now let's look at y equals 3 sine 4x. Okay, so what we're doing here is we're taking the x value and we're dividing it by 4. So it's at 0, 22.5, 45, 67.5, and 90. And then the y value we're multiplying by 3. So we got 0, 3, 0, -3, 0. Okay, and they say they want us to do 2 cycles. So we're going to go, so you notice, so how do I know how big to make it? Well, 1 cycle is going to take me 0 to 90, right? So if I want to do 2 cycles, I need to take it to 180. Okay, so I can call, let's see here. Okay, we'll call that 3. Okay, so there's, I'm just going up by 45s. Okay, and so let's put the points in now. Now notice how I didn't put points in for the beyond 90, and I'll show you why I didn't do that. Okay, so we've got 0, 0, and then let's call this let's call this 3. Okay, so there's 0, 0, and then 3, 22.5, which is kind of like halfway, and up to 3, and then 45 and 0, and then 67.5, which is halfway to negative 3, and then 90, 0. Okay, so this is one cycle, and so now, even though I haven't put points for the second cycle, it's just going to follow the same pattern, so I don't really need to worry about that. Just follow the same pattern, okay, so which is going to be like this. Okay, so you don't have to keep plotting points because it's going to follow the same pattern. Now, amplitude for this one is going to be 3. Okay, the period, which is basically how big the cycle is going to be 90, okay, which would be equivalent to pi over 2. Your maximum is going to be 3. Your minimum is going to be negative 3. Your x-intercept, so the way you want to indicate the x-intercepts, your x-intercepts are going to be every 45 degrees. So what you can say here is this is going to be n times 45. Okay, so it'll be like 0, 45, 90, 135, 180, and so forth. Your y-intercept is going to be 0. And then domain is going to be x. Is going to be it's going to be all real numbers because it just keeps going, and your range, because remember it keeps going on the negative part of the x-axis as well, and then your range here is going to be y is less than and equal to 3 and greater than and equal to negative 3. Okay. So now everything I've done here, I've just used the mapping technique in conjunction with the table of values. So you can do that, and you can also compare it by looking at, you can use Desmos, and Desmos does offer these type of functions. Okay, so you can now work on the questions that go with this.